Hey y'all, we are unlocking new cards in our proof card sets. So we're going to be unlocking inside of triangles. We're going to be unlocking side, 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 angle, side, angle, angle, side, and angle, side, angle today. So I just called it side, 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 and company. What you're going to be doing for your homework is just matching what goes with what, because what we're going to be doing overall is we're going to be making proofs that two triangles are the same as each other using these proof cards. This is really like the pinnacle of proving stuff in geometry in high school. So we're going to get super good at this. But first, what we're going to do is we're just going to walk through what each of these triangles look like. So let me just recap, though. The whole point is to prove that two triangles are congruent. And two triangles are congruent when all three sides of one triangle and all three angles of that triangle match all three sides and all three angles in another triangle. I'm going to tell you a secret. We're supposed to go through and prove the two triangles are the same by proving that all three sides and all three angles match. We're supposed to do an entire day of that. That's 5-1 and 5-2. We're going to skip that part because there are shortcuts. There are 4.5 shortcuts. We're only going to talk about 4 of them today. So here are 4 shortcuts. One shortcut is if all three sides, I should just say side, side, side. And I don't mean match in terms of like, hold on, I just want to block this off. I don't mean matches in like are equilateral, because they could be 2 scalene triangles. But if all 3 sides match in both triangles, these 2 triangles are congruent. Here's what this looks like. This could look like, here's a beautiful triangle right here. And I'll say this is a scalene triangle. Each side is different. And then I have a different triangle that's kind of like rotated. But they're the same. These 2 triangles are congruent. Those 2 triangles are congruent. Because even though it's kind of rotated, all 3 sides match in both triangles. This is because if all 3 of the sides match, then all 3 angles will automatically match. And we might actually go through a proof of proving that, but right now we're just going to say that that's the case. I'm going to show you a special version of this. If I have 2 triangles that share a side, like maybe it looks like this, like a little tent, and I know that these 2 are the same and these 2 are the same, then that middle line is also the same. I'm going to give you a prequel. This middle line is the same because it's exactly the same as itself. That's reflexive. So I just wanted to point out that if there's 2 triangles and it only shows you 2 sides are the same, but they share one, that third one is also the same. So these 2 triangles are also congruent. The left triangle and the right triangle are congruent. That's one shortcut. That's side, side, side. So if you click side, 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 it'll kind of walk through that. Here's an example of like the first one. All right, let's do another. Let's do side, angle, side. So another one is side, angle, side. These are in no particular order, so don't get too stuck on it. But it's basically if I'm going to walk around a triangle, if a side and the angle and the next side are the same, then everything else matches too. So it's literally a side. How do I say this differently? Hold up. Let me get my whiteout. There we go. Okay, so if there's 2 sides and the angle between them match, it has to be the angle between them. So for instance, if I have like this triangle and this triangle, I would have to go, I'm gonna go around the triangle. So side, angle, side matches with side, angle, side. Then those 2 triangles are congruent. Okay, did you notice that it went in order like side and then angle and then side? If this angle was somewhere over here, it wouldn't work. It doesn't work that way. The reason why is because it could be like more spread out or less spread out and still have the same length of the triangle side. So we have to be kind of careful, but it has to be side and then angle and then side. Side, angle, side. Matches with side, angle, side. Another example of this is if I have 2 triangles that are kind of like this, and I know that like these are the same and those are the same. I know that these 2 angles match because why? Have we done this enough yet? It's because of the vertical angle theorem. vertical angles are congruent. Hopefully you've seen that enough. So I know that these are the same because of a reflexive property, and I know that these are the same because it's vertical angle theorem. So it doesn't need to be marked as long as they're touching. They got to kiss. Got to get a little kiss in there. So that was side angle side. That's over here. And so that's an example of those two triangles. Now, they use the word included angle. It just means that the two sides include the angle in their little circle of friendship. But I use between in my notes, and it's the same. All right, still in no particular order, we're going to do angle, angle, side next. Angle, angle, side. That's the same as the last one, except it's the side that's being included. So this is two angles and the side between them. Okay. So this looks like if I had two triangles. I'm just going to make these kind of weird looking. They still look like two normal triangles. Okay, if I had two angles and the side between them, and two angles and this, oops, hold on, I need to just make that two, that's fine. So that shouldn't be that way, but that's okay. Then these two triangles are congruent because they have an angle and then a side and an angle. Angle, side, angle. Which one of these looks like it's more like the other one? It's fine, I don't care. So that gives me angle, angle, side. Oops. That's angle, side, angle. Let me just change that really quick too. You guys, nobody stopped me. Sorry, angle, side, angle. There we go, I fixed it. So angle, angle with the side in between them. I was looking at this down here on the side. That was my bad. Okay, so let's do the one that I just thought I was doing. Are there any special versions of this? Yeah, kind of. So it could also have a reflexive side or a vertical angle theorem side. It'll kind of show up sometimes, but this is more common with side angle side, and this is more common with side, but it really can be anything. Okay, the one I missed was angle, angle, side. So this one is two angles and a side not between them. It's called a non-included side, but I don't want to use that word because I don't want to say it twice, because you can just look at the other notes for that. Not between them, non-included side is what it's called, is the non-included side. So that would be if I have two triangles. These are not looking, they're looking less and less congruent as I draw them, but that's okay. So this might be like this: angle, angle, side, angle, angle, side. These two are congruent triangles. Okay, so it's another side. It's not the one that's here. That's the difference between these two, because they both have two angles and a side, but this one has two angles and the side between them, and this one has two angles and the side not between them. There's one more on here called hypotenuse leg, which is a specific right triangle thing, but we're not going to worry about that yet. We're going to worry about that later. And then I want to point out that there's one more combination of the letters, right? But like angle, side, side does not work. And it's not because I don't like swearing. Okay. It's because if I have, we're going to talk about this more later, but let me see here. So if I have an angle and a side, I can have an angle and a side the same length. So I could do like angle, side, side, angle, side, side. These are the same length, but one of them's going out further. So there's two triangles that could be a thing in angle, side, side. But that is just a thing that will never work. So it's not going to be an option. It also doesn't work the other way either. SSA is the same, side, 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 angle. It also doesn't work. One other thing is that sometimes in your textbook or in the world, because there's so many examples of these, this is also called SAA. I like AAS better. I don't know why. It's a personal preference. Don't come at me. But either one will work just fine. So this one could be reflexive. This one could be some vertical angles. This one could have vertical angles. This one could have reflexive sides. So don't think that it's only these two that can have that. I just wanted to point out that it's common here and it's common here, but these ones will have it too. Okay, your only assignment is I'm going to give you a card sort where you're going to try to match what goes with what. That's all you're going to do today. What we're going to do later is we're going to start doing proofs with these triangles, but I want you to get comfortable with the 4 shortcuts before we get into actually doing a proof with these. That's all I want you to do is figure out which one's which. It's a huge deal. It's an entire homework worth of a deal. Let me know if you have any questions. Please, please, please tell me if you have any questions, if you want more examples. And I will tell you the right answers probably in class or on the key. I don't know. All right. Have a great day. Bye.